Welcome back to BDBI Radio, and this is the fourth video and should be the final video for this webcast. And we're up to item number 9 here, and the differences between the SSAS Tabular model and SSAS OLAP. And this is a topic that many developers run into. It's one that I know in many different business application environments I've run into frequently, is security roles. In other words, defining what users have access to what data. Now, I'm not talking about users having access to tables. I'm talking about users having access to content within tables. So an example is certain brand managers or certain region managers or certain account managers only being able to see their accounts or maybe their accounts / products, depending upon how the authorization is broken out. And I'm sure many developers out there have run into the same types of circumstances. This is something that's always been a pretty major function in business environments, and I think if anything it's become even more important over the years. And I know from personal experience that sometimes when users or business managers have gotten the angriest about software not behaving the way it's supposed to be, it wasn't because of an error in the software or because of a wrong number on a report. Not that those things are good. They obviously aren't good, but where I've seen business users get the most bent out of shape is when someone was allowed to see data they weren't supposed to see, or even when there was a perception that somebody was about to see data they weren't supposed to see. So this is a pretty important topic. Now, over on the analysis services OLAP side, OLAP handles this pretty well in analysis services. We can define security roles for which users get access to which data. And you can do it either statically. Let's say that you have users or groups of users on the domain who are not supposed to see certain brand, or they're only supposed to see certain brands or certain geographies or combinations or whatever. You can define it statically, or if it's dynamic, let's say that you have a separate fact table and a separate dimension table, where the dimension table would have the users and the fact table would have the intersection points of what users are allowed to see which product keys or which geography keys, if you want to read it dynamically. Analysis services can handle either side over on the OLAP side. Now, sometimes you can do this without code. If you're defining it statically, you usually don't need to write any MDX code, or what you might write might be very, very small. If you do it dynamically, you actually will have to write a little bit of MDX code, and next week when I get into 13 areas of integrating MDX with OLAP applications, I'm going to show an example of that, so be on the lookout for that next week. Now the tabular side, I'm going to come back to the OLAP side in just a minute, but the tabular side has what initially appears to be pretty similar functionality. You can define roles. You can define users or groups of users who have access to certain dimension data. And that could even be done dynamically as well. Now, in a couple weeks, I'm going to have a show on DAX programming, and I'll show an example of dynamic security where the information is read out of dimension or fact tables. If you want to do a web search on it right now, there is an MSDN white paper, a very, very good one, called Securing the Tabular BI Semantic Model. That's the actual name, Securing the Tabular BI Semantic Model. It's a white paper that you can pull down that walks through the different functionality for defining security roles over the tabular side. And it even has some information on implementing it dynamically. However, there's one key aspect over on the OLAP side that doesn't exist on the tabular side that in some scenarios can be pretty important. I'm going to go over to Visual Studio and pull up the AdventureWorks OLAP queue. And I'm going to come down to roles. Now I'm going to start a role. I'm not going to save it, but I'm going to right click and I'm going to start a new role. And I will say that this is a role for bikes for North America. Now I certainly don't want anyone to have full control or process capabilities. I only want to be able to read data. And on the membership side, I'm going to skip this right now because I don't have any users on my domain other than myself. It's just a dummy local server domain. But here's where you would click Add, and you get the famous dialog to select users or service accounts or groups of users. Most people have been through this, so I'm not going to go into this interface, but that's where you would pick the users associated with this role. And on the data source side, there's only one data source in this cube, and it's AdventureWorks. So I'll say that they have read access to that, and I'll only give them access to the AdventureWorks cube, not to the mine customer. So if you have multiple cubes, you can define where you want the read access. Then I'm going to come over to the dimension data. And within the dimension data, I'm going to click the drop down for the different dimensions that are associated with the AdventureWorks cube. And I'll go down to the product dimension, and I will say that this is associated with the category level, so I'll deselect everything and I will pick bikes. And then, because I also said that I want to do this for North America, I'll go to the geography definition, and I'll go to the country level, and I'll deselect everything, and I will pick the United States and Canada, other words, North America. Now, we can do something very, very similar over on the tabular side. So if I hop over in Visual Studio to the tabular version of AdventureWorks, under the model there's an option for roles, and I actually already had one in here. I had a role called North America Road Bikes, and the interface here, it's a little different. In some ways a little bit easier because they've got everything combined into one dialog. In other ways, maybe just a tiny bit more detail, because we have to know the syntax here for geography definition, country attribute, and product definition subcategory. And here I made it road bikes instead of bikes, but still the same concept. Now we have to actually put it in brackets, and we have to know the logical operator for the or operator to say United States or Canada. But beyond that, pretty similar. Now here is where OLAP has something that the tabular side doesn't have, at least not without spinning an awful lot of DAX code. Let me come back to my slide deck here. The OLAP side has a feature that we can turn on and off called Visual Totals. The option, let me come back to the OLAP project. I realize I'm doing a lot of bouncing around here. Over in the Advanced tab in the OLAP project, there's a checkbox down here called Enable Visual Totals. And some people are thrown by what this actually does. Well, here's the best way to explain this Visual Totals option. I'll come back to my slide deck here. You might have a scenario where somebody can see 2 markets out of 10 markets. The question is, if someone runs an aggregation across all the markets, in this case they can only see 2, should the aggregated totals reflect just the 2 markets or all 10 markets, even though the person can only see 2? Now, you might say, well, since the person can only see 2 of the 10 markets, the grand total that they see should only reflect the 2 markets they have access to. Well, most of the time you'd be right. Most companies will want it that way, but certainly not all. There are some places that might want the user to be able to see the grand total for all 10 markets. Certainly not the breakdown of the other 8, but to know that, maybe in their 2 markets the sales have been $100,000, but across all 10 markets it's $500,000 or whatever the number would be, so that they could see what percent their 2 markets reflects out of the 10 markets total. Well, you can have the option either way with this option called Visual Totals. Now, it's off by default. My personal opinion, this should be on. When it's on, that means that any user aggregating sales by country, the totals are going to reflect just what the user can see. That's why they call Visual Totals. Well, in my opinion, this should be on because most businesses will want that behavior. But at least you have the option here for those few places that want the user to see all the totals, not just for the 2 countries or markets, whatever, that they have to be able to see. So Analysis Services over on the OLAP side gives you the choice. Over in the tabular model, there is no such option for that. This is something that many companies are not going to miss, but certainly not all of them. I had one client, one very big client, that needed the equivalent of non-visual totals. So you'd have to write a fair amount of DAX code in order to implement that. So coming back here to my slide deck, on the issue of security roles, at first you would think that the two of them are more or less about the same, but as it turns out, OLAP has a little bit more functionality. So give the nod here, give the slight edge to OLAP because of the option to set visual or non-visual totals. And again, next week on BDBI Radio, I'm going to do an example of dynamic MDX code for dynamic security capabilities on the OLAP side, and then I'll do the equivalent functionality on the Tabular side a couple weeks after that when I have a similar program dealing with DAX. So that's security roles. All right, moving on here, I'm going to look at deployment. Now this is another topic where we could spend almost an entire hour and a half just talking about what gets deployed. Well, first of all, on the OLAP side, when you deploy a project and you physically create an OLAP database, the resulting database is a physical database in the Microsoft OLAP Analysis Services format. So over here in Visual Studio, in my I'll close my role here. I'm not going to save it. And I go back to Solution Explorer. See, this is running a little slow here. Oh, always lovely when that happens. All right, we'll just restart this. I'm running an awful lot of things at once here right now, so it's okay. And I'm not going to recover anything because I didn't want to retain anything, so I'm just going to say do not recover, and I'll just reopen the project. Now this project itself, the project that we use in SQL Server Data Tools or in BIDS to create the OLAP cube, this doesn't represent the OLAP cube per se. This is the project that we use, that we ultimately deploy, that's going to read the data source to create the physical OLAP cube. So this project reads from the AdventureWorks data warehouse, more like a data mart, and it's going to create an OLAP database, by default the same name as the project unless we change it, that'll have two cubes with these cube dimensions inside of it. Now, if I want to know what the name of the OLAP database is that's going to be created, I can right-click here and go to Properties, and under the deployment area, well, the name of the OLAP database is going to be AdventureWorks DW 2012, etc., etc. And it's going to be deployed on this particular server. Now, you have the option in Visual Studio and in SQL Server Data Tools, if you want to have multiple configurations to deploy to multiple servers, you can. But that's going to deploy the OLAP database to that particular server. Now, if I go open Management Studio and point to my Analysis Services instance, in this case localhost SQL 2012, I'll see that OLAP database. As a matter of fact, if I just simply open, I'm really tempting fate here by opening so many things at once here, but I'll risk it. Open Management Studio, and I connect to my Analysis Services instance of that's my local host name, and then SQL 2012. I will see over here on the left-hand side under the available OLAP databases, there's that AdventureWorks database. And I can obviously write MDX code here in Management Studio to test it out. I can run reports and reporting services against this OLAP database because it's available here on this server. Now, a key point here. The OLAP cubes, when they're deployed and when people run against them, can be much larger than available server memory. There are OLAP databases out there that are in the hundreds of gigabytes and even beyond. And that's fine. The OLAP engine, the Analysis Services OLAP engine, has a set of methodologies in place that can read more data than what's available in server memory. Hopefully you're running on a dedicated Analysis Services server. But even if the cubes are larger than server memory, that's not a problem. And remember, OLAP cubes can have partitions with aggregations in it, so that when people run at higher levels like year and quarter and region and brand and so forth, the Analysis Services engine can read those aggregations, which will obviously result in much faster performance. And as I also mentioned, the Analysis Services engine will read partitions in parallel. If a cube has been partitioned or a fact table has been partitioned across years, and someone runs a query that spans all years, the engine will read those partitions in parallel if it can. And again, even if those partitions are larger than server memory, it can still handle it. So this particular approach, this particular methodology has been in place for years. It's tried and true. Now on the tabular side, it initially seems to be somewhat similar. I'm going to come back over here to SQL Server Data Tools for my tabular project. We can right-click here on the project, and we can do a deploy, and that's going to actually deploy a tabular database called, in this case, ADW 2012 Tabular Model against this particular instance. Obviously, I have separate instances here. SQL 2012 for my OLAP engine and SQL 2012 Tabular here for my tabular instance. And if I come over here to Management Studio and I now connect to my tabular instance, well, I've got ADW 2012 Tabular there. Now, by the way, that second one here, if you're wondering what that's for, if you remember a while back I had done a test run to Excel, an incremental test in Excel using my tabular model from within SQL Server Data Tools. That's part of the reason that this separate one is actually out here. Now, here's a big difference between the tabular model and the OLAP model. The tabular model, the resulting database, it is compressed using the XVelocity engine that Microsoft has written, but the resulting database cannot exceed server memory. It cannot. So let's say that you originally had a source database that was a terabyte. Now the resulting tabular model might wind up being 100 to 200 gigabytes depending upon what level of compression you get. Well, that resulting tabular model has to be able to reside once it's compressed in server memory. If not, you can't use it. This is an in-memory analytic database. Now, these tabular databases can be partitioned, but that's only to optimize any processes that update the partitions. That's not going to factor into what partitions get written in memory for any one query. And also, there are no built-in equivalent of OLAP aggregations in the tabular side. So there's certainly one benefit here on the tabular side, and that's that it's in server memory. Whereas over on the OLAP side, part of it might be in server memory, part of it might be on disk. So certainly, if something can fit in server memory, that's obviously going to run very, very fast. But then once things get very, very large, over on the OLAP side, you have the ability to implement partitions and aggregations. And those features either don't exist to the same degree in the tabular side, or you flat out don't have aggregations that you have on the OLAP side. So some differences here once you get beyond the original basic deployment capability. Again, for very, very large applications, OLAP is going to be the way to go. If something can fit in server memory, and if you can live with some of the other issues in moving to the tabular model, then you might want to try looking at the tabular model. But those are the differences in deployment. All right, number 11 here, and again, a promise that next week when I take a look at writing code against OLAP cubes, I'm going to actually give an example of this, and the same thing over on the tabular side. Surprisingly, the way that we would incrementally update an OLAP cube and the way we would incrementally update the tabular model aren't as different as you might think. There are certainly some differences here, but they're not shockingly different. In both instances, we use what's called XMLA. XMLA stands for XML for Analysis Services. It is a series of processing commands where we can do things like process update, process full, process index, process incremental, and we use those commands on different aspects of the cube. For instance, process update we use on dimensions. Process full and process incremental we use on fact tables. And so those processing commands we can implement either on dimensions, on fact tables, on partitions, and we have the ability to do that in SSIS with a particular task that generates XMLA code against a cube. Or if you're using .NET, you can utilize the Analysis Services object model using ADOMD.net. Now on the tabular side, it is actually much the same way. We use XMLA commands to update either the entire deployed model or individual partitions. Now, I mentioned that next week when I cover MDX, obviously XMLA is different than MDX, but because it's a programming topic, one of my 13 tips is actually going to be on this very topic. And when I cover DAX in a couple weeks, in fairness, I'm going to do the same thing on the tabular side. Now, there's not a lot that's been written so far about XMLA commands against the tabular model. Certainly some, but not a ton. My book recommendation at the end, if I come out to my book recommendation at the end here, the Analysis Services book written by Chris Webb, Alberto Ferrari, and Marco Russo actually cover a chapter, not a couple of pages, but actually a chapter on updating tabular models using XMLA code. So again, one more reason to get that book. All right, so both models have the ability through XMLA to incrementally update either all of the cube or database or part of it, and you can point directly to partitions. Obviously a very important capability. Now sometimes you might have to actually write some script code, especially if you've implemented dynamic partitioning. If you've implemented dynamic partitioning and you obviously don't know the name of the partition at any one time that you're going to be updating, then you're definitely going to need to write some script code, say in an SSIS script, to actually generate some code to hit the partitions dynamically. All right, I'm actually going to, I said this is going to be the last video. I'm going to actually break this up and do one more. I've got 2 items left here. One is accessing tabular model and OLAP model from client tools, and then a feature matrix at the end. I'm actually going to stop this video and start one final one to cover these last 2 items.